Hi, today we're going to talk about calculating compound interest and what it is. You need to get a calculator. I'm going to be using a TI-84 graphing calculator, but you can use any calculator, preferably the one that can do multiple operations at once. So we have Raquel, who invests $1,000 in the account that pays 5% annually, and each year she earns interest on the original investment of $1,000. Colin invests $1,000 in the account that also pays 5% annually, but his bank adds newly earned interest to his balance each year. So how's it going to work? So Raquel's interest, if you do 5% of 1,000, that's $50. So she's going to earn 50% interest by the end of first year, and her balance will be $1,050. But because her bank continues to add the interest on the original amount, she's going to continue adding $50 each year. And then she's going to have 1,100 here, and then she's going to have 1,150, and then she's going to have 1,200, and then she's going to have 1,250, and then she's going to have 1,300 by the end of year 6. So it's pretty easy with her. So let's do it with Colin. So Colin's also going to earn $50 after the first year, and his balance is also going to be $1,050 at the end of year 1. But to calculate the interest for the second year, you are going to use this amount. So if you take 1,050 and multiply it by 0.05, that's going to give you $52.50. So his balance at the end of the second year will be this plus this, which will be $1,102.50. So now we're going to find 5% of that number. So we're going to take 1102.50 multiplied by 0.05. That's going to give us 55.125, so $55.13. And if we add this number and this number, that's going to give us $1,157.13. So now we're going to find 5% of that number. So 1,100. So we're going to multiply that number. Oh, I'm sorry, it's going to be 63. My apologies. Multiply that number by 0.05. That's going to give us 57.88. So we're going to take 1157.63 plus 57.88. It's going to give us now $1,215.51. You're going to find 5% of that number times 0.05. It's going to give us now $60.78. We're going to add these two numbers together. So 60.78 plus 1215.51. It's going to give us now $1,276.29. I'm going to multiply that by 0.05 to get the 5%, which now is $63.81. And we're going to take 61.81 plus 1276.29. And now we're going to get $1,338.10. So if you look at this, as time goes on, Colin keeps earning more and more interest because of this. So if we go here, Raquel is getting paid simple interest, and her balance can be computed by a very simple formula. We're going to take 1,000 plus $50 each year times number of years. That's a linear model. Colin is getting paid what's called a compound interest. Compound interest is interest earned on top of interest because we have new balance. So for the first year, it's going to be 1,000 plus 50, right? But we're going to look at that a little different. Each year, Colin's balance is going to be 105% of the previous balance. So for year one, it's going to be 1,000 times 1.05. That's 105%. Why 105? 100% of the original balance plus 5% is the interest. So that's for the first year. For the second year, it's going to be 1,000 times 1.05 times 1.05, and so on and so forth. So his formula can be written as 1,000 times 1.05 to the power t, which is the time, the number of years, and that is an exponential expression. So this is the formula we are going to use for computing the balance in an account that pays compound interest. It looks fairly complicated, but P is the principal, which is how much money you initially invested. R is the interest. It's very important that you remember to write that as a decimal. T is the number of years, time, and N is the number of compounding periods per year. That's one of the most confusing things to students for some reason. What does it mean? That means how often per year you are going to earn interest. So if it says it's done annually, it's going to be happening just one time a year. If it's done semi-annually, you're going to do it twice a year. Monthly, there are 12 months in a year, you're going to do it 12 times a year. Bi-weekly, well, let's do weekly first. Weekly, there are 52 weeks in the year, so it's 52. Bi-weekly will be half of that, 26, and daily will be 365. I know there is a leap year, and the question sometimes is how do we account for that? The difference between 365 and 366 is going to be so minuscule that we are not going to have to worry about that. We are always going to use 365. The formula requires some care when you enter the values, so let's try to do that. I have some problems here, and we're going to try. So Javier invests $3,000 in an account. He earns 6.5%. So this is the value of our principal. This is the interest, but we need to remember that it's going to have to be entered as a decimal. Divide 6.5 by 100. That's 0.065. Do not enter that as 6.5. You will start getting huge numbers. T is 8. Now we just need to figure out the values of n here because we have 4 different problems. So what we're going to do is we're going to use our graphing calculator and we're going to take the formula. So the formula says for the first one, n, we do it annually, one time a year, n is 1. So 3,000 times 1 plus, the rate is 0.065 divided by 1, which is n, to the power of nt, 1 times 8 years. $4,964.99. Remember, this is dollars. We're going to have to enter that write that as a decimal rounded to 2 decimal places. So this is the expression we're working with. And it's going to give us $4,964.99. When you do it monthly, it's 12 times. So it's going to be exactly the same, except this number is going to be 12. Instead of 1, we're going to put 12. Instead of 1 here, we're going to put 12 as well. So it's 3,000, 1 plus 0.065 divided by 12 to the power 12 times 8. 5,039 and 1 cent. So it's going to be 3,000, 1 plus 0.065 over 12 to the power 12 times 8, which is $5,039.01. So you should get the idea now. Here, n is going to be 52. So I'm going to type it all the same way, except this is going to be 52 and this is going to be 52. And here n is going to be 365. So let's go ahead and do that. For this one, it's going to give us 5,400 $44.44. And for the last one, we are going to use 365. And that's gonna give us $5,045.85. So what I want to point out to you as our last thing, as the number of compounding periods increases, so as you add interest more frequently, the amount that you're going to end up with is going to be larger because everything else is the same. It's still $3,000, still the same interest rate, still the same length of time. But because we do it more and more frequently, we are going to end up with more money in the end. Okay? If you have any questions, post them in the comments. I hope this helps.